Okay, last video, another sample AP problem. I find this particular type of AP problem to be like a highly likely thing they'll put on the 2 free response questions that you'll eventually do when you take this thing online. So you've got another accumulator function, but you're anchored to -3, kind of annoying, because you're not anchored to -5. And the first thing you want to do is just find g of 3, which means integrate this function from -3 to 3. So if you go from -3 all the way to 2, you should have a big triangle right here, which is 5 wide and 4 high. So that should be half of 4 by 5, plus an extra like tiny little triangle when you go from 2 to 3, which is 1 by 1, but you're down, so half of 1 by -1. This should be 20 minus a half. This is, or sorry, half of 20, so 10 minus a half. This is 9.5. You can write your answer as 19 halves, or you can write 9.5. It doesn't really matter, and I think we should be good. B is a little weirder. B wants to know when G is increasing and concave down. So if you're increasing, the derivative needs to be positive, and if you're concave down, the second derivative needs to be negative. So you need to find g prime of x, which according to the FTC is just f, because it's defined as an accumulator function, and you need to find g double prime, which is f prime. And we're looking for g prime to be positive. So anywhere on this chunk, because g prime is f, and we need to be above the axis to be positive, and g double prime, aka f prime, to be negative. So we have a graph of f, so we need f's derivative to be negative, and f's derivative is negative when it's decreasing. So any place on the graph where the function is above the x-axis and decreasing is a winner. So we're talking from -5 to -3, and also from 0 to 2, because g prime of x, aka f of x, is positive and decreasing. Done. That's it. That's the whole thing. On to part C, which is a little funny and weirder. So part C asks you if h of x, they bring in some other function, is g of x divided by 5x. H of x is g of x over 5x. They want to know h prime of 3. So I don't know, we got to take the derivative of h, and that's going to mean we do the quotient rule. So h prime of x should be g prime of x times 5x minus g of x times 5, all divided by 5x whole thing squared. This should just be a quick little quotient rule where you do your u prime v minus your u v prime divided by v squared. And now we just plug in 3, and whatever we get, we get. So we want g prime of 3 times 15 minus g of 3 times 5 over 15 squared. And whatever we get, we get. So g prime of 3 should be f of 3, based on our previously used fundamental theorem of calculus that g prime of x is f of x. So we just need to find f of 3. So f of 3 looks like it's right here, and it looks like f of 3, aka g prime of 3, is just -1. So this should be -1 times 15 minus g of 3, which we actually did in part A of this question, and we should have gotten 9.5. So this should be g of 3, which is 9.5 times 5, all over 15 squared, or 225. I'm going to leave this as 15 squared for simplifying purposes, and this is going to be like a lot nicer at the end. So this actually winds up being negative 15, where if you think about this, the key to me for simplifying this would be to factor out a 5. So this should be 5 times, this is negative 15, so we're leaving behind a negative 3. If you factor away a 5 from here, you should just be leaving away behind the 9.5. And then if you think of 15 squared as 5 times 3 times 5 times 3, I would lose these 5s, and then we should get negative 12.5 divided by 9 times 5 is 45. And then I think we're okay. I would actually double the top and bottom here to get a negative 25 divided by 90 to clean that up a little bit. And then you can reduce by a factor of 5 again, and I think our nicest answer, if we divide top and bottom by 5, should be 5 over 18. So I'm getting negative 5/18, and then we've just got one more little piece for this, and then we're kind of okay. And I think this one's kind of funny because it gets another function. You bring in some, I think we're up to our 4th function now that I think they call p, and p of x is f of x squared minus x. So we want the slope of that function, and we want the slope of that function at negative 1. So we want to just do p prime of x, which should just be f prime of x squared minus x, all back inside for a 2x minus 1 because of the chain rule. And then we want to plug in negative 1. So if we do p prime of negative 1, we're doing f prime of negative 1 squared, so 1 minus negative 1 times an extra 2 times negative 1 minus 1. So that's going to be negative 2 minus 1 more. That should be negative 3. I'm going to throw that in front, and then we need f prime of 2. So we're basically kind of good to go so far. So how do we get f prime of 2? Well, fun fact about g prime of x. G prime of x was just f of x by our FTC, so g double prime of x should be the same thing as f prime of x. So we need f prime of 2. So anyway, we have a graph of f. F prime should just be the slope. I guess this is technically the second derivative of g, but that's not really relevant here. So I don't know, we don't really need that. We just need to find the slope of this f graph at 2. So at 2, we don't want 0 here. 0 is f of 2. We want the slope here, and it looks like we're going down 1 over 1, down 1 over 1. So this should be negative 3 times negative 1, which is positive 3. And we have found our slope. Sometimes these problems ask for the whole tangent line. This one's just asking for the slope. So you're done once you found the slope. No reason to write the equation of a line. But I think we're all done here. And that's the end of the second practice sample AP question. Kind of funny. A little weird, just takes some getting used to. There should be 2 practice ones for homework, and I should reference what year they come. So come to office hours if you need help with any of this stuff, but I would rank this as a highly probable question to be on the AP Calc exam. One of